start by covering greatest common factor and factor by grouping. Greatest common factor is also sometimes referred to as greatest common divisor. Same thing. Okay? Greatest common divisor. There are many different ways of factoring. We will be going back and forth throughout the rest of the semester, depending on the problem. Sometimes we'll use more than one method for any particular polynomial. Greatest common factor and factor by grouping is kind of the baseline. As we go through, your job, your most important job, is to ask yourself, what methods do I need to use to factor? It's not always going to be told for you. As we're learning and going through, the directions will say factor by grouping or factor by trying to find the greatest common factor. But as we move on, it's not going to tell you what to look for. You need to keep that in your mind. I need a factor. I need to use this method or another method. Okay? Reminder that factors are just a bunch of things multiplied together. Okay? In order to get a term. So we can take any integer and we can write out the numbers that multiply together to get that integer, and that lists out all the factors. So for example, if I take the number 27 and I want to list numbers that multiply to give me 27, give me two numbers that I can multiply, get 28. Multiply to get 28. 7 and 4, right? Are there any, now so these 7 and 4 are factors of 28. Are there any other numbers I can multiply to get?
2 and 14.
2 and 14. These are factors. 2 and 14 are factors of 28. Okay? Now, when we're looking at greatest common factor, we want to identify the prime factors of a number. Okay? Prime factors. Prime factors. Does anyone remember what a prime number is?
Nothing can multiply.
Your idea is right, but your operation is wrong. One in itself. Okay? A prime number only has factors of 1 and itself. Okay? So for example, 2. The only things you can multiply to get 2 are 5, 1 and 5, 7, 1 and 7. Those are all prime numbers. So if we want to identify the prime factors, we need to continually factor the number until all we have are prime numbers. Okay? So, if I take 28, and I want you to identify a prime factor. Well, we've already got 1, we got 7, right? I can break apart 28 into 7 and 4. 7's a prime number. Is 4 a prime number? No. So I need to factor 4. What does 4 factor into? 2 and 2. Is 2 a prime number? Yes. So my prime factorization is 7 times 2 times 2. Those are the prime factors of 28. So when we are looking at finding the greatest common factor, especially when we're looking at the coefficients, we need to identify what the prime factors are so that we can compare them. Introduction, we're finding greatest common factor. So when we're trying to find the greatest common factor, the greatest common divisor, we want to find the GCF of the numerical coefficients first, and that's going to involve identifying the prime factors and seeing which ones each term have in common. Variables are much easier to identify the common factors for, and then we just take all those prime factors and multiply them together, and that gives me my greatest common factor. So let's start with looking at some variables. I have x to the third and x to the seventh. I'm going to write these out. As you become more proficient and see a pattern, the process will get much, much shorter. If I want to factor x to the third, I get x times x times x. That's my prime factorization. X to the seventh is going to be x times x times x times x times x times x times x. So to find the greatest common factor, I want to see what do they have in common. What do they have that's the same? What do those terms have that are the same? They have a coefficient of 1. X, how many x's? 3. They have 3 in common. Okay? So if they have x times x times x in common, then my greatest common factor is x to the third. That's what they have in common, x to the third. Looking at B, okay, well now I have coefficients and I have variables, okay? So I need to factor my coefficients and I need to factor my variables. What's my prime factors of 6? 2 and 3. 2 and 3. What are my prime factors of 4? 2 and 2. What do they have in common? 2. And just one of them, just 2. Okay? X to the 5th is going to be how many x's? X to the 3rd. How many x's do they have in common? 3. So my greatest common factor is the 2 that they have in common and the x to the 3rd that they have in common. All right. Let's look at our a's. I've got a to the 3rd, a squared, and a to the 4th. So 3 a's, 2 a's, and 4 a's. What do they have in common? 2 a's. So I have a squared. All right. Look at our b's. B squared, b to the 5th, b to the 7th. How many b's do they have in common? 2. That's my greatest common factor. What do you notice about GCF for any variables? What do you notice about the greatest common factor whenever we have variables? Least. What part? The lowest exponent. It's the lowest exponent. When I look at x to the 3rd and x to the 7th, x to the 3rd is my GCF, the lower exponent. 5 and 3 is the 3. My a's, the lowest exponent on an a was a 2. For the b's, the lowest exponent was also a 2. So that's going to be the GCF with my exponents. So the exponents are going to be a lot easier. You're going to look for the lowest value of among your exponents on each variable. And that's going to be what you use for your GCF. Now, what we're going to do is we're going to take the GCF and we're actually going to use it to factor. And I want you to remember that factoring is division. So when we find our greatest common factor, we're going to divide each and every term by that factor in order to rewrite our expression. So, let's look at our factors 6, 9, and 12. What are my prime factors of 6? 2 and 3. What are my factors of 9? What are my prime factors of 12? So
3 and 4.
3 is prime, 4 is not. So factor 4. 2 and 2. So 3, 2, and 2. So 3 times 4 gives me 12, which is good, right? But 4 is not prime because I have other factors besides 1 in itself. A prime number is only in fact a number is prime if its only factors are 1. I can multiply.
Oh, so does that mean all numbers?
No, not all numbers. Not all odd numbers are prime.
How do we know which
A number is prime if its only factors are 1 in itself.
Oh.
The larger numbers you get, the less likely it is going to be prime.
So 5 is prime.
Yes.
And
9's not. 9's odd, but it's not prime. Three times six. Okay. All right. So, looking at, I don't erase that. Looking at my numerical coefficients, what do they have in common? Okay. So the numerical part of my greatest common factor is 3. Now we need to look at the variables. I have x to the third, x squared, and x. I don't need one of them. They all only have 1, 3 in common. So I'm only going to circle one of each of these. So now if I look at x cubed, x squared, and x, what's the greatest common factor among those? Just x. Because the lowest exponent is 1. Okay? So my greatest common factor is 3x. The numerical part is 3, the variable part is x. Now what I'm going to do is each of these terms is going to be divided by 3x. But here's the thing I need you to remember. Once you've identified your greatest common factor, you know what you're going to divide by, you need to write your GCF and then a set of parentheses.
Wait, why are we dividing?
Because that's factoring is division. It says to factor. Factor is division. Factor is undoing multiplication. The opposite of multiplication is division. Factoring is division. But we're not getting rid of 3x. We're not getting rid of our greatest common factor. We're dividing it to separate it from the rest of the terms, but we're still going to keep it. It's still there. We're just separating it. Okay? And what's inside the parentheses is what's going to be left after we do the factoring, after we do the division. So if I look at my first term, I've got 6x to the third divided by 3x. What does that leave me with? 2 squared. 6x to the third divided by 3x is 2x squared. 9x squared divided by 3x. X to the third divided by x is x squared.
When you divide it, it's not.
Yeah, we're just doing the division.
You said x to the third divided by
X to the third divided by x is x squared. X squared divided by x is x. 12x divided by 3x is 4. Now, here's what I want you to look at and notice. We took our greatest common factor, we divided everything, we ended up with another polynomial inside of parentheses and our greatest common factor outside the parentheses. Look at, oopsies. I wanted that to be a highlighter, not a pen. Try that again. Poor choice of color. Try a different color. That'll be smarter. There we go. That'll work.
I think it looks good on the other 3.
When you identify your greatest common factor, the factors that are left over are what's going to be your factors inside of your parentheses. I took a 3 out of the 6, I'm left with a 2. I took a 3 out of the 9, I'm left with a 3. I took a 3 out of the 12, I'm left with a 4. I took an x out of x cubed, I'm left with x squared. I took an x out of x squared, I'm left with x. I took an x out of x, I'm left with nothing. Okay? So, what you're left with, that's what's going to be your factors on the inside. But everything is all still there. We just undid the multiplication. If you're ever unsure, you can always just go and distribute and make sure you end up back at the same answer. you can always check by taking your answer and multiplying, and you should get back to there. Because that's what we're doing. Factoring is undoing the multiplication. If you want to make sure that you undid it correctly, do it again and multiply. Make sure it's the same. Okay? Yes, this is your ending answer. That's the factor. All right?
How long until we have a quiz? No,
Tuesday.
it goes all the way to the end.
No, just the first 2 sections. Tests will be in 3 Fridays. All right. So, you guys want to be the only class that doesn't finish this today? What are my factors of 14? 7 and 2. Are those prime?
Yeah.
Okay, good. What are my factors of 7? 7 and 1. 7's prime, right? And then I've got another 7, right? So I've got 7, 7 and 1. Okay, so there's my factors of each of those. Now, I have x to the third y, which is x, 3 x's and a y. I've got x squared y, which is 2 x's and a y. And I've got xy, which is an x and a y. What variables do they have in common? 1x and 1y. Okay? They've got an x in common. They've got a y in common. And my coefficients, what do they have in common? A 7. So what's my greatest common factor? 7xy. Okay? 7xy is my greatest common factor. So all of those will be divided by 7xy. So 7xy, and then in parentheses, I simplify my first term. What am I left with? And what else? 2x squared. Okay? Second term, what am I left with? 1x, or x. And then what am I left with on the last one? If I divide something by itself, it's still 1. It doesn't go away. Because I don't have an x left.
Oh, you're right, because you have to take it away.
Yep. Okay. Now, your GCF does not have to be a monomial. Your GCF can be a binomial. Okay? And this is something that will actually force to happen on some of the problems, but we're going to give it to you now. I have 2 terms here, both of them being multiplied with a factor of x plus 2. I have 6 times x plus 2, and I have y times x plus 2. So, for this, my greatest common factor is the quantity x plus 2. Both of those terms have something being multiplied by x plus 2. So because it's in that parentheses, that entire grouping is a factor. And since they both have that in common, it's the greatest common factor. Alright? Now, the greatest common factor is x plus 2. So now I want to factor it, right? So I need to divide both of these by the quantity of x plus 2. So that's my greatest common factor. Now I need to ask myself, what am I going to be left with? If I take 6 times x plus 2 and I divide it by x plus 2, what am I left with? Just the 6, right? Those cancel out. If I take negative y times x plus 2 and divide it by x plus 2, just left with negative y. So now I have it factored. What's my greatest common factor for b? Y plus 1. Right? My GCF is y plus 1. So I'm going to write my GCF And then I'm going to start a new set of parentheses. What's left in the first term after I factor out the y plus 1? xy. What's left in the second term after I factor out y plus 1? Negative 1. Negative 1. Divide something by itself, it's 1. And since it's minus. Now it's factored. We are going to force this to happen on these. Everything so far has had 1, 2, 3 terms. When I have 4 terms. When you have 4 or more terms, we use a method called factor by grouping. Because if I look, do I have a factor that is common among all 4 of those? No, other than 1. But that doesn't help, right? Factor out of 1, nothing changes. So 1 is the only common factor among all of these, so I can't factor out a greatest common factor. But we can do what's called factor by grouping. And I look and I see, okay, well the first 2 numbers have a common factor. And the last 2 terms have a common factor. Let's factor those out and see if we get something quite magical. What's my common factor for the first 2? Y. Which leaves me with what? Good. What's my common factor for the last 2? Which leaves me with what? Now this looks like these. Right? Same thing? Pretty much? So now that I have something times x plus 1 and something else also times x plus 1, I can factor out the x plus 1, and that leaves me with y plus 2. Huh? Yeah. Frankie, looking at my first 2 terms here, x cubed plus 4x. What's the common factor with just these 2 things? So when I factor out the x, what am I left with? If I divide 4x by x, what am I left with? 4. Okay?
Wait, why would it go x to
I factored out of this one.
Why is it x squared? Just make
Okay? Now, the second one. Do I have a common factor with x squared and 4? No, but that's okay. I mean, I do, but nothing super obvious. Is this already the same as this?
Yes.
So what can I factor out of it that won't change it? 1. You can still factor out a 1. Everything has a factor of 1, right? If I factor out a 1, it doesn't change it. Still leaves me with x squared plus 4. And now, those are the same. So I have 2 groupings that are identical. So just like we did on this page where I had, hey, this grouping's the same, and this grouping's the same. Let's factor out that grouping. And what do we have left? Let's factor out this grouping of x squared plus 4. If I take the x squared plus 4 out of this first term, what am I left with? X. And if I take it out of the second term, what am I left with? Plus 1. Factor by grouping. So factor by grouping is used most often when we have 4 or more terms. Okay? But we can also use it with trinomials. We'll see it as we get to some more complicated polynomials later. All right? Now, when I look at this one, 2x minus 9y, do I have a common factor other than 1 with 2x minus 9y? No. Do I have a common factor with 18 and xy? No. So I can't factor by grouping as it is now. But what I can do, if I can erase, is I can rearrange it. I can use my commutative property and group things together that do have a common factor. What are 2 of those terms that do have a common factor? 2x and xy. So let's rearrange it. 2x minus xy. And then I've got 18 minus 9y. Rearrange it so that I have common factors within my desired groupings. What can I factor out of 2x minus xy? X, and that'll leave me with 2 minus y. What can I factor out of the second grouping? 9, which leaves me with 2 minus y. I factor out a 9. 18 divided by 9 is 2. 9 divided by 9 is 1. Now are these the same? Yeah. So now I can factor out 2 minus y, and that leaves me with x plus 9. So you can rearrange the order of the terms to adjust your grouping. Just make sure you pay attention and track your negatives. Make sure they stick to where they are. I have minus 9y, so it's a negative 9y. Negative xy, negative xy.
Wait, but how do you factor out 9?
The common factor of 18 and 9 is 9. 9 times 2 is 18. Okay? Do I have a common factor here? X squared. That's my greatest common factor is x squared. So what am I left with? 2x minus 1. What am I going to factor out of that? Negative 5. If I factor out negative 5, what am I left with? Not plus 1, minus 1. Because I'm factoring out a negative 5. 5 divided by negative 5 is negative 1. And factoring out that negative 5 is very important because I need these to be the same. Which means I need the sign on the 5 to change to a negative. So that it matches with the negative 1. So I have 2x minus 1. Good.
How much is left?
That's a good question. Go ahead and take your stuff. You can go.